Photonics West. Wish we had a bigger crowd here to talk about one of our newly launching products, which is called Vertex Textured Film and is a universal device carrier specifically designed for our optics customers. We supply transport and handling devices for a wide variety of different applications. I'm learning how to use the computer here. And we appreciate the time and opportunity to speak here at Photonics West. For those of you that aren't familiar with GelPak, we provide highly engineered handling transport solutions for a wide variety of industries. And we do that by developing a family of polymer-based carriers and design films that provide maximum protection during shipping, handling, processing, and transport of all types of delicate devices. That sounds simple, but it's not. It's quite a challenging technology to master, and we've become experts in this for operating in this space for nearly 50 years now, from our first founder, which developed the first GelPak in 1972. Since then, we have continuously explored and investigated new materials, new form factors, to safely and securely handle and transport your delicate products. Why do we do this? It's an integral part of being able to deliver a finished good in many instances, whether it's within the manufacturing process where something needs to be immobilized and transported, or if it's for shipping a product to an assembler or another step in your manufacturing process that is required to complete your finished good. And this is particularly of interest now, especially with the chip shortage that we're all encountering. It's more important than ever that every chip that is shipped to an assembler, no matter who manufactures it, gets there safely and is usable. What we're going to talk specifically about today is our Vertex family of carriers. Those are the most widely adopted products of GelPak for the optics industry. We do have many silicon-based films that are used for similar applications, but clearly silicon isn't always something that is feasible for optics applications. And what we have to demonstrate today is our Vertex textured film, which is a micro-textured film and has many different product configurations and form factors. Something like a 4x4-inch tray with the textured film, all the way up to a JetX tray form factor. And whether you're moving devices around for electrical test or quality checks, immobilization while moving very delicate devices around your process can be super critical to high yield and good performance of the finished product. Excuse me. So we wanted to talk today about how component immobilization and our ability of our film to be compatible with pick and place is possibly a good fit for a challenge that you might be facing with your manufacturing process or shipping of a finished product. So as we go through a few slides today, one of the things I would ask is to think about how you might use a Vertex textured film product in your process. When we develop the technology, it's a bit of a problem, a bit of a solution looking for a problem, should we say. So the attributes we think lend themselves very well to photonics applications, but we have the experts of the world here to tell us if we're right about that. The film itself is a textured elastomer film, and it is a non-adhesive micro-textured bump, and the hold of the chip or the optical device occurs through van der Waals forces. So the benefit of that is that it does not leave behind any residue. It has very strong holding power, but can be removed from the textured film very easily with minimal residue. It can be delivered in a film, and the film stack is what you see here on this slide. We have a pressure-sensitive adhesive, a substrate that our textured polymers extruded onto, and then a cover sheet goes on top of that to protect it prior to use. So to dig in a little bit more to the benefits of the product, it is a non-adhesive holding force, which is very critical for a number of applications. We have found adoption of this product in semiconductor as well as optical applications for immobilization of silicon, glass, metal, silicon carbide, and GaN devices. So a lot of interest from the compound semi space. And the reason is the extremely low residue. If you think of a semiconductor application where this is very likely to lend itself, if you think of hybrid bonding, where you're bonding two wafers together that have through silicon vias, and you need to move those wafers around the process before they're ready to be stacked together, they can be moved on and immobilized on a textured film JetX tray, removed and have no residue and be ready immediately to be mounted onto another wafer. That's just one application where we are seeing adoption. And it is also compatible with pick and place equipment if you take some special precautions into consideration. Now, the other big benefit of the textured film is it is a universal carrier. So you can have devices of multiple sizes on one single tray. So quite often, I don't know if it's as common in the optics space, but for semiconductor, if you want to use a JetX tray to move a device around your manufacturing process, that tray has to be customized, and you either need a custom mold or you need to CNC a pocket into that tray to immobilize the device. Whereas with textured film, you could use the same tray to move a device of any size, roughness, shape, without having to have a custom-made tray and pocket to hold that device. The other big advantage is it's reusable. So we have methods for cleaning the film, which allow it to be used for multiple use. It can be used multiple times with the same performance. Another interesting benefit of the film is what you see here in this picture is a piece of glass laid on top of our textured film. And what this is meant to show is these dots in the center. That is the only point of contact that your device makes with our textured film. And even with that minimal contact area, we still get very great hold. And why we are over in this area is due to wanting to do some demonstrations. So if you look at a very small device, such as this, I drop it onto the TX film, no pressure, no downforce, doesn't come off. But if I want to remove that, there's almost zero force to pull it off. So that is what lends itself so well to the low residue and the very effective immobilization. It comes in 3 different TAC levels. That is selected through the size of your device, the roughness of the substrate that you're putting on. If you have a very rough substrate and a large device, maybe like a QFN, that would be something where you would maybe need the high TAC version. Or if you were going to use the film to ship a device, you would maybe want to go with the high TAC. But then there's other applications where we have very, very small die, sometimes that you could very easily lose. You don't need such the high holding force, and you can go with something that is on the lower side. So we do have a low, medium, and high TAC available. As I mentioned, no silicon, no phthalates. It's ultra low outgassing, less than a ppm of hydrocarbon, and on the low and medium TACs. Temperature range is it's effective from -10°C to 50°C with a very long shelf life, which again lends itself well to the reusability of the product. So as I demonstrated, the strong holding force is very attractive benefit, but it's really the easy release that is truly the differentiator of this. There's many products out there that can immobilize a device. There's not many that are then where that device can be easily removed and there's no foreign material or residue left on that device. So we, as you saw, I could drop that down onto the TX film with no downforce, and it immediately is held in place after the component placement. It does take about 5 minutes if you wanted to have optimal hold of that device. But again, that's all done through less than 2% of the device's surface area being contacted by the film. We have developed the film and are now working on the different form factors to bring this film to market. So we are very well known for our 2-inch and 4-inch vacuum release trays. So we are providing it in a 2-inch and 4-inch form factor. We are also providing it in the GelPak form factor, which can be used for multiple devices and typically used for in-process handling for our current applications where this is in use. We also have the ability to put this on a film frame. So if you are doing pick, inspection, and reconstitution, you can pick, inspect, and reconstitute onto a film frame carrier with our textured film and still maintain your wafer shape of any size wafer. It's also available in sheets. Some folks would like to put it onto their own form factors, their own trays, their own fixturing. This way we can provide a JetX size sheet, and then you're free to cut it into any shape and form that you want, and still very effective and usable, and can be applied through the pressure sensitive adhesive. So it sounds too good to be true. Okay, well, there are a few drawbacks, and not necessarily drawbacks, but just things that need to be taken into consideration if you're using TX film for pick and place. You want to prevent excessive downforce. As you saw, I could just drop the device on and it is still able to be held effectively. You don't need to smush it down into the film. What happens then is you increase your contact area, and then you can increase the challenge to the pickability can become more difficult if you really stuff it down into the film. We do recommend the use of a rubber tip or a collet that would be specific for the component that's being picked off, and you want to make sure that you reached full vacuum before picking. Minor adjustments that all pick and place tools are capable of modifying these input variables. So we do have a number of publications out about this. It's a Bioinspired film. We have a number of nicknames for it. We have a German customer who calls it chicken skin. We have another customer who refers to it as gecko feet. But all of these Bioinspired names come from the physical appearance of the film. But we have YouTube videos available that show the use of this product. It's one product that I can honestly say COVID has made a challenge to launch this product because over video it's difficult to show how impressive and unique the film is. The way we have found the most applications for this is bringing it to a customer and letting them play with it and doing a little show and tell, which is why we thought today would be a good opportunity to allow folks to try the film with different die sizes. And then you can usually see light bulbs go on where people can think of uses for it in their process, where they may need a mobilization temporarily or a mobilization for shipping of a product. We wanted to also mention a few other products. That's the textured film is one of our newest launching products. But we do offer a number of other products that are specifically designed for photonic applications. We have a Vertex, which is a similar type of film that is designed into a tray with specific areas that are recessed. And those are very commonly used for loading FACs, where the FAC, just the end of each bar, contacts the Vertex film, and the other area is recessed. So you can see in this picture here, the FAC is bridged across the recession in the film, and the contact of the FAC is only on very small areas of the end of each FAC. And we can tune the force and the texture and tack of those as well, and is also suitable for automated pick and place as well as manual pick and place. This mask's driving me crazy. We have a third product that has been specifically formulated for photonics applications. As I mentioned, historically we're known for our silicon-containing films. We know that can be a problem in some applications, and we have developed another carrier type that uses a polyurethane film, and that's our AvAPV and VRP device carriers. These are also suitable for pick and place, and it's a similar material to the previous Vertex carrier that I showed, but in this instance there's no recession, it's a uniform film, and that comes in a poured gel box as well as in our vacuum release form factor, where if you're not familiar with those, we have a mesh and a film that goes on top of that mesh. The tack of the film is what holds your device in place, and then when it gets to the assembler where you need to do your pick and place, you then pull vacuum. That mesh is then pulled to the bottom of the tray, reducing the contact area on your device, allowing for very easy and fast pick and place onto your assembled product. So this is a third product of ours that is very specifically formulated and seems to be getting great adoption in the optic space. I'd say the most success for this is also with FACs and SACs predominantly right now, but we are seeing new uses as we get this more penetrated into the market. And that, I think, wraps up all of the slides that we had, and we'd be happy to do some demonstrations, or if anybody would like to do some picking and placing of your own to see the low force that's required to pick it off of the film, we'd be happy to let you play with some of our devices here, or you're welcome to swing by our booth, which is 1459. But thank you very much for your attention. I appreciate you guys sticking around to watch. Thank you.